Welcome everybody to the Hawkridge Systems webinar on optimizing your computer hardware and software for Solidworks performance. I'll be your host today. My name is Alex Taguchi. I'm the current technical support manager for Hawkridge Systems. I've held a variety of technical roles here at Hawkridge, supporting a variety of products. And one of my passion projects over my years here has been figuring out how to get the most performance out of my SolidWorks applications so I just can get my designs and my job done a little bit faster. And so one of my responsibilities is actively benchmarking and testing a variety of computers, laptops, desktops, CPUs, GPUs, even testing alternative technology like virtual desktop infrastructures and cloud technologies, just to see what the best is out there for our own engineering team here at Hawkridge Systems. So let's get into it. Now, I know a lot of you here consider yourselves hardware gurus, and that's the awesome and challenging, exciting thing about computers and technology is that there's always something new, right? Every 9 months, every year, something new comes out. And what I'm going to do right now, just real quick, is just cover some fundamentals. The four major computer components that we're going to talk about are going to be the CPU, the GPU, the RAM, and the SSD. A little bit further on in the presentation, we are going to dive into some very specific models that we're recommending, and then we'll also talk about some operating system fundamentals, settings that you might not be aware of, and also some system options and document properties within SolidWorks that you may or may not have enabled or disabled, so you can see if you've got that going. And the very last thing I'd like to touch on before we move forward is I hope that a lot of you here may get some resources and tools available to you, so that way you can talk to your IT manager or your boss and help craft a plan on replacing or upgrading your computer, so that way you've got the latest and greatest, so that you can get your jobs done faster. So let's talk about components of a computer. Really, there's four main ones: the CPU, GPU, RAM, and SSD that we're going to focus on. And just some real brief definitions here. The CPU, that's the central processing unit. So we're talking about the most important component of your computer build that will determine the overall performance of SolidWorks. There are three main specifications that you should be aware of when you talk about processors or CPUs, and that's clock speed, the hertz rating that the processor processes, as well as how many cores it has. That's just how many simultaneous parallel processes that it can complete at a given time. And also the third specification that you're not going to see listed on any spec sheet anywhere from Intel or AMD, but it's important to mention, and it stands for IPC's instructions per clock. And what that basically boils down to is in a given 1 hertz or however many clock speed that processor can run, how many instructions can it handle in that 1 hertz? So every year when new processors come out, the chips companies say, well, we've increased our IPC by 10% or by 15%. And you're never going to see a hard number associated with it other than that percentage. And so the best example I can give you is that, let's say, for example, you have a processor from 5 years ago that ran at 5 gigahertz. Well, if you bought a processor today, a modern 11th gen, i7 or i9 at 5 gigahertz, the instructions per clock of the current gen processor are going to be significantly higher than those from 5 years ago. So that way, in that same hertz rating, your current gen processor will be able to calculate or handle many more instructions in that same given time or hertz. So it'll be much more efficient and faster. So the best way that you can increase your IPC in general is just to stay current. So the newer processors always are going to have a higher IPC rating than the previous generation processors. In terms of clock speed and cores, we're going to talk about that a little bit in a couple slides here in terms of which you should prefer and what matters. But in general, what it comes down to is that clock speed is the one you should be caring about in most scenarios, because almost all SolidWorks tasks and features and things that are typically might be slowing you down are single threaded. So having more cores isn't always beneficial in those scenarios. So the next component is the GPU. and that stands for Graphics Processing Unit. And this is really responsible for one thing, and that is the graphical performance of SolidWorks. So all the faces, the edges, and the vertices that you see on your screen, and how fast that it's going to respond when you input a mouse input. So for example, if you're panning your model, if you're zooming in and out, or if you're rotating your model around, and this includes drawings, like if you're panning your model, your views around, your GPU is going to determine if that action is going to be nice and smooth and have a high frames per second, or it's going to be really choppy and really laggy. And so that's really all the GPU is going to be responsible for. So if you're noticing that if you're opening up really large assemblies, or hyper complex part files like injected molded parts that have a lot of edges and vertices, and your graphical rotational performance is pretty choppy, then you may want to consider a higher end GPU the next time you look to build your system. The third component is RAM, and we're going to go over this pretty quickly. It stands for Random Access Memory. It's hyper-fast temporary storage that's used by your CPU. And what this really comes down to is whether or not you have enough to load your largest data set. So as you load more and more, or greater and greater assemblies and drawings and parts, and just opening them, which loads them into RAM, if you use or consume all the available physical RAM available to your system, what ends up happening is your operating system will begin to start using a page file or virtual memory, which is going to be slower than RAM. So you don't generally want that to happen, because that's going to start slowing slowing you down. So essentially, you just want to have enough RAM to be able to open the largest data set that you might have, and you can analyze that on your system to see how much you're using, pretty basically. I'll talk about that on the next slide here. The last thing here is your storage drive, and typically now we're just seeing the acronym as SSD, which stands for solid state drive. You might have seen HDD and things like that in the past, but really this is the permanent storage device on your system, and the current technology that's by far the fastest is called NVMe, and there are specifications within that, like for example, PCIe 4 NVMe is the fastest. But really all this determines in terms of your SolidWorks performance is going to be how fast you open files and how fast you can save files back to your SSD. So if you are seeing, you're opening up very large files and you're storing them locally and it's taking a while to open and save, you may want to consider looking at what SSD or what type of storage drive you have in your system, and look at buying an NVMe in your next build. So how do you know when it's time to do a computer upgrade? So this is a question that I get pretty often, and I'm going to talk about some pretty simple things that everyone has, or are free tools that you can go and get, or resources available to you that you can use on your system right now, to take a look at how fast your system is right now compared to maybe others in the community. The very first thing is a SolidWorks RX tool. So if you have SolidWorks installed, just go into your start menu and search RX, open it up. There's a benchmark tab. And on that benchmark tab, you just hit start. This is a standard test that SolidWorks includes with every install, and it tests a bunch of things like opening files, rotating, rebuilding, render test, things like that. And then it gives you a score at the end. This is a very rudimentary score, but it's a good kind of like quick snapshot view of how your system does compared to others. Because at the very end, when you see your score, you can say compare to others. If you click that, it'll take you to the SolidWorks benchmark site, and then you can see how others have performed in the same exact test. And you can look at what processor they have, how much RAM they have, how much GPU, what GPU they have, and then do a quick comparison to see, is my computer underperforming, overperforming? Is it right where I expect it to be? So it's a pretty good and handy tool that everyone can use, and it really only takes about 30 minutes to run the benchmark. Secondly, everyone has the Task Manager. It's a Windows OS tool. Just again, search Task Manager in your start menu. And what's awesome about the Windows 10 Task Manager is that on the right-hand side, or on the left-hand side of the Task Manager, it now lists all the four components that we've talked about. You've got your CPU, you've got your RAM or memory, you've got your disk, and you've got your GPUs listed down at the bottom. And let's say, for example, you're working on one of your more complicated files and you open it up and you're waiting for that blue spinning circle to complete. If you look at your task manager under the performance tab, you can get a quick at a glance view as to which component is being taxed. So that way you know maybe that's an area where you might need to upgrade or go a little bit bigger on your next build. As you can see from my sample screenshot, this is from my machine. I was doing a rebuild and it was taxing one of my cores on my CPUs. The file was very large. I think it was like 400 features or something like that. And you could see that my RAM is getting close to being maxed out. I'm at 16 gigs and almost in 10.3. And then towards the bottom, you can see that my disk is not being utilized at all because I've loaded the file entirely into RAM. And you can see that my GPU is hardly in use as well too during a rebuild. So not being taxed, there's no load there. There are some other free cool tools out there. There's one called CPU-Z and GPU-Z, and those are awesome just for identification, because if you look in your Windows system information, it'll give you some idea of what CPU you have and things like that. But if you use those tools, the CPU and GPU-Z, it'll give you a lot more granular data about the amount of cores, the clock speed, the cache, a lot of different things that you can use, and also what generation your chips are coming from, to compare against others and maybe look at computer builds moving forward. And I'd like to give a huge shout out to Puget Systems. If you haven't heard of them before, they are what I consider the gold standard in terms of third-party benchmarking for a variety of applications. So they have created their own standard SolidWorks benchmark with the help of SolidWorks, actually, that gives a much more granular look or at all the different tasks. So they look at file open, they look at rebuild, they look at simulation, they look at rendering, they look at graphical performance, and they have benchmarks built for just those tasks, and they're much longer benchmarks. So you get a better idea of which processors perform better than other processors, and they compare AMD and Intel and generations of Intel processors. As soon as they come out, they're awesome at very reliable benchmarks, and our recommendations mirror their recommendations almost every single time in terms of what computers and what processors and things like that are performing well for SolidWorks. So I highly recommend take a look at their, this is pugetsystems.com, and go to blog, and then you can filter for just SolidWorks content. The last tool that I'd recommend here is SpecView Perf 2020. This is another standard benchmarking tool that if you wanted to actually do the benchmarks yourself, you can download that, and it can actually test your SolidWorks installation to see how well your system is performing against others. And there's a lot of results that you can compare against out there. Okay, now there's the Puget Systems. This is the latest article that they put out there in terms of the latest AMD chips and how they performed relative to the Intel 10th gen chips from last generation. There's an argument to be made in how to approach a plan. We're buying 25 to 30 engineering workstations here at Hawkridge Systems amongst our engineering staff. So we're buying quite a bit of machines here, and it's real difficult to determine, okay, who gets what, when do they get it, all that fun stuff. So I've worked with IT pretty closely on determining like what's kind of the best fit, and so what we've come to over the years is, there's an old argument where that says, well, I just want to buy a high-end computer that's going to last me for the next 5 to 7 years, and we've taken that approach before, but we found that doesn't really work anymore, and at least for us. And the main reason for that is computer technology changes so rapidly now that the computer that you buy now is likely going to be eclipsed, right, in the next 3 to 5 years by something new in the future. And so to expect that it will perform at a high level for that long period of time is fairly unrealistic. And then the other thing that we found is that engineers' tasks change. So what you're doing now may not match what you're doing in 5 to 7 years. Maybe you're not doing any simulation now, but maybe you will be doing some in the future. And so what we found is that we stick to a 3-year kind of rule of thumb life cycle for computers. And the reasons for that is, number one, it matches the computer warranty, which is nice. The second is that it helps us stay current with modern technology as new chips and technology and storage and all that stuff comes out. We're staying pretty fresh because we're always using the latest version of SolidWorks. So that way our machines are able to take advantage of the latest features that SolidWorks keeps adding into the new versions. And then the other is that, again, our engineers, they change roles, they change tasks. They might be doing rendering more, or they might be doing just design, or they might be doing a variety of different things, tech support. And so their tasks generally change. So we try and just buy the fastest possible machine for those engineers for the tasks that they have at that time, and then plan on replacing it roughly in 3 years, and then reevaluate then. That's generally how we do it. Let's move on to kind of the build. So what do we recommend right now? And so before I talk about kind of what our recommendations are, I do want to talk about some terminology. I know more definitions. Just last time I'm going to do definitions, and then we'll move right into the meat and potatoes here. I have some terms there at the top there: recommended, certified, tested, ISV. There's other validated, and all sorts of fun stuff. Our recommendations are going to meet the minimum requirements as listed at the SolidWorks system requirements page, and then higher, because we find that the minimum requirements just they don't cut it anymore. So that just so you know, it always meets the minimum, but then it's like minimum plus. So the SolidWorks also uses some other terminology like tested and certified in ISV. You'll find ISV on hardware websites like Dell, Lenovo, and things like that. It stands for Independent Software Validation, and it just means that they provide their hardware to different vendors like Dassault Systems for validation. And so what SolidWorks does is they have a hardware lab that they receive a ton of different computers from all the different vendors and graphics cards on their own, and they put it through a battery of testing. And if it has passed their tests, they then list it on their certification site. So if you Google SolidWorks hardware certification, it'll take you to a website that lists every single laptop, desktop, graphics card, and what version they tested it on, and what graphics card driver that they tested it with. So you can see over the last, this is, I think they have stuff from 7 years ago now, to see, which machines that they are currently certifying. They are a little bit behind right now. I've talked to the manager over there, and they did tell us that due to COVID, they haven't been able to keep up to date with as the influx of hardware that they're receiving to then publish on their website. So we have seen that be the case where a brand new laptop is shipped from some of the vendors. It doesn't quite show up on that hardware certification site yet, but as long as it's considered workstation class, it likely will end up on that site. But awesome resource for you guys to take a look at. So what is the build? What does the build look like? Let's talk about that. Well, at the beginning right now it's easy. There's only one OS to choose from. That's Windows 10 Pro 64-bit. And the next thing that we want to talk about is the processor. So there's really only two choices or two vendors that you can choose from right now. There's Intel and there's AMD. And I'm going to talk about both real brief, or in kind of the differences. We used to never really talk about AMD, but in the last 3 to 4 years, they have really produced something that's competitive for SolidWorks. So on the Intel side, the chips that you'll see here listed on the high side, the i9 11900K and the i7 or i9 10900K. What the first two numbers of that 11900K and 10900K, that just identifies what generation they're coming from. So once again, this comes back to like that IPC number and the instructions per clock. The 11900K are going to be slightly higher IPC than the 10900K because those are the 10th generation, which came out last year. So that's kind of how they do their naming convention. And then their i9s are considered typically like their highest end chips that they have in that Core i series. So the 11900K, awesome chip. Those have a base clock speed of, I think, around 4 gigahertz, and they can turbo up to 5.3 gigahertz. So their theoretical maximum clock speed is among the highest that you can buy, which is fantastic for SolidWorks. For laptops, you've got similar models, 10885H and i7 10875H for the mid-range. And these are generally what we're buying too for our machines too. We typically buy in the mid-range unless we have some very specific use case scenarios like 3D scanning, simulation, flow simulation. Those users were pretty much only buying i9s for those guys. And then from AMD, you've got the Ryzen 9 series 5950X, Ryzen 9 5900X on the high end, and then on the mid range, you've got the 5800 and 5600X. And then for laptops, I don't have anything listed there. It's not that they don't have chips out there, it's just that there's not a single laptop on the SolidWorks hardware certification that has an AMD laptop posted. So it's just not fair to talk about them until they start showing up on the SolidWorks certification site for the laptops specifically. But the argument for AMD versus Intel, I mean, you could go either way. I'm not really going to try and make a case for either or. I would recommend taking a look at Puget Systems and looking at all their benchmarks to kind of see which ones perform better in certain tests to see if that's something that would benefit your specific workflow or what kind of files you work on. But the general like high level overview is that if you're looking for more cores, the Ryzens are going to be just better because the 5950X has 16 cores. Nothing from Intel has even close to that. The 11900K, I believe, is an 8-core CPU, and the 10900K is a 10-core CPU, and that's on their high end. So that's why if you're looking at cores and multi-threaded type of scenarios, then you're probably going to be better off suited for AMD. But again, take a look at the benchmarks and see what's a good choice for you. I don't really show any older stuff because again, we're looking at getting the maximum performance, and that is going to come from current generation technology due to that IPC change that you see, generationally over year over year. Okay, what's next? Well, the next component that we want to talk about is graphics cards, and I specifically say workstation class graphics cards. So I do want to kind of define the NVIDIA Quadro RTX, and AMD Radeon Pro categorization versus non-workstation class graphics. And so I just want to talk about the ones that were our recommendations. So on the NVIDIA side, you've got the NVIDIA RTX, a Quadro RTX 4000, and the ones that just launched, I think last month, the RTX A4000. You'll notice that they dropped the Quadro name for some of these, but they are still considered in the workstation class. It's just a successor. They've just had a slight name change. And then for the laptops, they're the same models. For the mid-range, you've got the Quadro P2200s and T1000s, and the Quadro T2000s and T1200s for the laptops. I think on most of the machines we're buying now for the laptops, we're buying the T2000 and T1200s. On the AMD side, you can see that we've got some mid-range W5500 Radeon Pros, and then desktop W6600 for the laptop. They've got some similar models as well there too that you can take a look at. You're going to see the AMD's offered a little less in the GPU side. When you go to your hardware vendor, you'll find that by and large they mostly offer NVIDIA, but AMD is an option that do get hardware certified from SolidWorks. So just talk about the reason for me, bringing up that workstation versus non-workstation graphics cards. It's not that you wouldn't be running an unsupported platform. Let's say, for example, if you had a workstation class graphics card like a NVIDIA GeForce RTX card. It's just that graphics card was never submitted for testing, and nor will it ever be, and it will never be certified by SolidWorks. It'll never show up on their hardware certification site. They only test and certify the workstation class. So will it work? Maybe. Your mileage may vary. So it's a big roll of the dice, and so we generally just don't recommend it, and we just stick with workstation class graphics for the best stability and performance. The fourth component, I'm kind of combined them into one line item there, and that's RAM and storage. Again, I mentioned NVMe storage is king, so it's hard not to get an NVMe storage drive these days. And then RAM. So on the SolidWorks certification or minimum requirements page, they list 16 gigabytes of RAM. We are finding that, like on my system, like from the screenshot before I showed you, I had one part open and I was already at almost 67% of utilization of my RAM. We're going to start buying for our own internal purposes 32 gigs moving forward this year, and we find that that's probably going to be enough for a while for most of our team here, and I think that would match the same for most users. If you are, again, like one of those power users loading large studies for sim and flow or doing heavy renders, then you might want to consider 64 or 120. I think that definitely makes sense. RAM is one of the cheapest components of your build, so just go higher, go more. One other thing I just wanted to mention too is that we do have a questions panel over on the right-hand side, and if you've got any questions, go ahead and enter them there. I've got an engineer on standby who's going to be reviewing those, and I'll try to get to some of them at the end as well, if we have if with time permitting. So how else can you get performance? Well, definitely you can get some performance from software upgrades. Well, every year SolidWorks likes to show us, especially their R&D team likes to show us this slide that has a bunch of graphs on it that show SolidWorks 2020 is faster than 2019 by 10% in certain scenarios. SolidWorks 2021 is faster than 2020 by 15% in certain scenarios. So that's what I want to talk about real quick. Like, for example, some very specific scenarios. 2020 had some interesting software improvements that that some are active, meaning you have to like turn an option on or use a feature to get that performance improvement. Some of them are just back end. You just install the latest version of SolidWorks and you just automatically get those performance improvements. So in PDM in particular with 2020, they added some background search, especially with the quick search function. So if you're a heavy PDM user and you're not on 2020 yet, especially for those working in remote or across a VPN or WAN environment, 2020 got some nice improvements for just day-to-day PDM tasks. They also added the detailing mode for drawings, and they added a new enhanced graphics performance mode in 2020. They've made some significant improvements to that in 2021, and I'll talk about that in the next one here. So one of the things that they did was, which is kind of strange, up until 2021, a lot of what would appear to be graphical calculations in your drawings were all CPU calculated. And so with this new enhanced graphics performance mode enabled, they're now able to offload a lot of those calculations that were burdening your CPU now onto the GPU. And so those are some of the ones listed there. I'm not going to go into the details of what those are, but they definitely, especially like panning, zooming, rotating it, and just refreshing drawing views, I've noticed that there's been an improvement because now the CPU doesn't have to calculate some of those edges that it used to have to calculate. Another nice little one for those sheet metal users out there. Let's say, for example, you had a whole bunch of, you had a linear pattern of, forming tools like ribs or something. Sometimes calculating the flat pattern was really slow, and so switching from your part to your drawing and letting that flat pattern view regenerate would take a little while. Well, in 2021, they made a nice improvement there that it essentially like excludes that pattern from the calculation if it hasn't really changed. So it's a nice little feature. And then also, again, carrying on the theme of PDM improvements, especially for remote users, that check-in performance and state changes and other just day-to-day tasks, you don't have to turn anything on, these are just passive upgrades, have been greatly improved. And we've seen a lot of awesome results from some of our customers that, especially since their workforce has largely moved to remote and their latency is impacted due to VPN and different internet connection settings and all that stuff, that just by upgrading to 2021, which is at SP 4.1, which is the current one right now, suddenly some of their like check-in performance and state changes just dramatically, it almost became as if they were local and not remote. So some awesome results there. And then every year or two, they're also trying to take advantage of updated solvers for sim and flow simulation. So that way, if you do have more cores, it can then start utilizing more of those for its final solves. Okay, let's talk about the operating system. There's really three things to talk about with the OS, and that is the graphics card and then these two settings I got listed here. Now, graphics card drivers, I think it's a hotly debated topic. Everyone's got their personal opinion and experience from trying different drivers and doing an old one, doing a new one. And some of you may have multiple versions of SolidWorks installed on your computer like I do. I've got 2020 through the new beta that's out. And so it's always kind of a question like, okay, which certified driver do I put on my machine if there's different versions listed for the different years of SolidWorks? Well, the general recommendation from SolidWorks is just to load the latest for the latest version of SolidWorks that you have. So if you've got 2021 on your system, but you might have some other older versions, just install the one that's certified for 2021. It's likely going to be fine for the older versions as well. And so for the most part, you're gonna find that the NVIDIA R460 driver is the currently certified driver for almost all NVIDIA cards, and the AMD 21Q1.1 being the standard certified or the certified branch driver for AMD cards. I did take a look yesterday at the site, and there are some new graphics cards like those new RTX A4000s and A5000s that they're now starting to test with the latest NVIDIA driver, which is R470. So just take a look at that site. This is the hardware certification site for the latest one for your system. So that's the best recommendation. There's another link to it on this page that says, if you have a graphics card that's not listed here, click here for a list of our legacy cards. And it'll give you a list of some of the older cards from like the Kepler generation, things like that, and which driver they recommend for those. So again, take a look at this site because it's a really good resource in determining which driver you should be running. Touching on drivers for a second again, there is a the NVIDIA control panel. So I've seen some people try and gain a little bit more graphical performance by changing settings in the NVIDIA control panel. SolidWorks' recommendation is not to change from the base profile, just leave it alone. And so that's where we go to as well. Like you can go in there and change anti-alias and things like that. And generally we see very little to no improvement by changing those. And we're just gonna take the R&D's recommendation and just go with base profile. The two other things that I want to mention here is automatic system managed page file. So this is that thing I mentioned when we were talking about RAM, and that if your RAM is consumed to around, I think the threshold is 80%. I forget what the exact number is from Microsoft. It will start using your storage drive as RAM, and that's what this setting controls. Again, I'm deferring back to what their team, SolidWorks' team, their development team has said, and they say to leave this set to default, which is automatically manage page file. So some of you may have changes in the past, like in older Windows XP in 7 days to like eke out a little bit more performance in certain scenarios or allow you to open greater file sets. Almost all of that is irrelevant now. And really what you want to leave this is automatically manage and for maximum performance and stability. And if you are simply just running out of RAM, again, RAM is one of the cheapest components, just buy more, upgrade. It's usually pretty simple for that specific setting. User account control is another thing I just want to mention here. This is less so much about performance, but more so about just general, I guess it is general performance for SolidWorks. They have told us that their QA team tests SolidWorks with UAC set to the default. And I've seen this actually cause problems where if you set it at the most strict setting at the top, it can cause issues with installation and just generally using SolidWorks, like changing system options and not letting you change settings because it's trying to write to the registry. So we recommend the default setting for user account control. All right, so let's get into some SolidWorks settings. There are hundreds of settings in SolidWorks, and SolidWorks by default ships with all of them at a specific set of standards. And they're not always set for performance as the priority. And so I do want to add an asterisk to some of these because you should, before turning on or off some of these settings, you should get familiar with what those settings are actually going to do, because they can change your workflow, especially with like the auto update stuff with drawings and assemblies and things like that. So I'm going to talk very quickly about kind of some of the ones that are a little bit obscure. So the first ones that I usually turn off on my system are all the internet connected settings. So there's by default, when you launch SolidWorks, it's trying to ping the SolidWorks website for the latest news, features, and updates. And also, when you do searches in the upper right-hand corner, it's going to automatically include 3D Content Central results, and I usually don't want to search that. I'm trying to look local on my C drive. So you can turn off those internet connected, and this can impact your just launch times. So if you think that you're seeing that splash screen for too long, if you turn some of these off, it actually should improve that launch time because it's now no longer checking for the latest internet connected information. Now there's the 3D Content Central option you can turn off. I think that's off by default. Here's another one that I just want to mention, but just be careful about. So there's two settings here on the screenshot: show content while dragging your drawing view and allow auto update when opening drawings. If you uncheck the allow auto update, you just need to be careful that you have that option off, and it's a system option, so it'll affect every drawing that you open. So you may want to play around with that to see if it is making a noticeable improvement, or just simply opening your drawings in lightweight is better, or maybe take advantage of that new detailing mode if you're on 2020 or 2021. So yeah, just be careful, but those can improve your open times just because it's not going to just automatically try to update. And here are some more auto update settings for assemblies. So you're going to find these under your system options under assemblies. The screenshot I sent here is actually not the standard large assembly settings, but those would be the ones that I would set if I just cared about maximum performance. And there's one in particular that that is off by default, and that's that second option there. Do not rebuild when switching to assembly window. So that's for example, if you've got the drawing or if you've got the part open, you switch back to the assembly, it doesn't automatically rebuild the assembly every time. Also suspend automatic rebuild at the bottom, that's not on by default. So that will just, there's certain events that will trigger an assembly to just automatically rebuild. And so that will try and suspend some of those from occurring. And then you'll get the little, rebuild icon when it's informing you like, hey, by the way, I need to update because I've identified some things have changed and maybe some reference parts. Now here's some things that are going to impact, I think, that are pretty straightforward that I think most people can just turn off or enable, and you'll get some nice performance improvements. These are all graphical. So there's that new setting called the Enhanced Graphics Performance mode down at the bottom. That is available only to 2020 and newer versions of SolidWorks, and really allows SolidWorks to harness newer graphics cards technology. So if you've got an older graphics card, you might not see as much of a difference, but if you've got some of the newer graphics cards, then yeah, your panning, zoom, rotate performance can be significantly faster. The other thing that you can do is turn off the animation speeds. So by default, when you select two faces and you're trying to make them to be coincident or something like that, that shows a quick animation. Well, you could just turn that off entirely, so they just snap together. So allow you to just add mates a little bit quicker. One asterisk I'd like to add about that is that if you accidentally select two things on accident, it's not going to show you, like if you take a bolt and it just flies off into space, since there's no animation, you're not going to see what direction it went off to then find where that component is floating in space. But yeah, if you want maximum performance, you can turn off those animations entirely. The other thing that on here is the level of detail slider. So that setting is kind of it's a legacy setting in that when they introduced that, what this is determining is it's saying, okay, if I were to target 30 frames per second at all times when I'm panning, zooming, and rotating my models to make it nice and smooth experience, how much simplification of the geometry can I do? So if you have this set all the way to the right, it'll simplify your model. So if you open up a large assembly and you rotate it around, all of a sudden things start turning into simple polygons. That's what the setting is doing. It's reducing the level of detail dynamically, and then as soon as you let go of the rotate, it then resolves it and it's higher fidelity. Well, with modern graphics cards, you almost never need to mess with this. They're so fast, especially with the Enhanced Graphics Performance mode on. I just turned that off, and I found that the performance to be actually faster because now it's not having to calculate what the simpler geometry is and then going back to the more complex geometry. So if you have it off, it's just high fidelity all the time. The other couple quick settings, I think they're pretty standard. Everyone's probably seen these. I don't use real view, I don't use shadows, and I don't use ambient occlusion. There's now with modern graphics cards, you're seeing minimal impact with these settings, but they do add overhead to your graphics performance. So if you are looking for maximum performance, you can turn those off and you'll gain a little bit of frames per second. The other graphical setting I'd like to talk about, and this is something that comes up pretty frequently in tech support, is we see users have their document properties set at the maximum or very, very, very high. And all this is doing is it's controlling the the edge fidelity of your model. It's not actually changing your geometry in any way, but it is just changing how smooth your edges look in your graphics on your monitor. And what we found, and definitely this is true, there's a reason why that the very right is colored red, and it's because you almost nobody should be putting their slider up in that range. It gets exponentially finer of edges when you go into that red zone. And what you'll find is that if you do that, and then just hit there, switch back to your assembly or your part, and just hit Control Q to do a full rebuild, you find that the rebuild, to just do the graphical rebuild, it might take much longer. So if you're seeing that at the bottom of your, I think at bottom left or bottom right hand corner of your screen, it says updating graphics, that might be what's caused by this setting might be just cranked too high and causing that graphic setting to just take too long. So do a quick test, open up your file, go to the document properties, slide these all the way down to the bottom, go back to your model, and then retest and see if the performance changed. If it did, then you know that it's just the slider was just set too high. And about third of the way, is about what we recommend for in most cases. And then maybe if you need to take a screenshot, you don't want this, your circles to look like triangles, maybe turn it up a little bit and then turn it back down when you're done. Here's more of those animation transitions. So this is under System Options View. So you can animate a lot of these things, like when you switch from front view to top view, it'll actually animate your model moving. Hide show components. If you've got a component and it's opaque and you want it to hide it, it kind of goes to that weird, it goes transparent and then disappears. If you want it to just disappear, you can just turn that animation off. Same thing for isolate and things like that. Another one that I don't have on here is transparency. Transparency adds significant overhead to your graphics card. So if you are working on a pretty large assembly and you have a lot of transparent objects, especially transparent appearances that are stacked on top of one another, that adds a pretty big drag or load on your graphics card. And so I recommend in those cases, just create a second display state for that assembly and just get rid of those transparent appearances, and then do your modeling and do your tasks in that display state, and then switch back to the other display state when you need to show the model with the accurate appearances. There's a couple other ones like locking toolbox rotation. This is a feature they added many years ago, so that way your degrees of freedom in terms of your components are locked in place without adding additional mates, because the more mates you add to an assembly, the greater the load is going to be on your processor and your RAM when you start rebuilding things. So the fewer the mates, the better. And one of those ways that you can lock that degree of rotation but not actually adding an actual mate feature is by turning that system option on for Whole Wizard and Toolbox, which locks rotation for concentric mates in Toolbox. Cool little feature. There's another one here where you can increase your auto recover time, rather than 10 minutes or 15 minutes, because what it's doing is it's literally just doing a save to that designated location of the file that you have open. In case SolidWorks crashes, you can recover from it. Well, if it's saving too frequently and you have very, very large files open, you might be seeing delays or stutters just from it trying to do that auto recover save. So maybe increasing that duration. There's another couple settings here. This is something that isn't on by default, or is off by default, which is reference documents specified in file location. In general, you want to have that include subfolders unchecked, because what that's going to do is it's going to prevent your search routine looking in every folder on your C drive for file references, which you may want if you're trying to move files around, but in general, you're not going to want that on all the time. You're going to want that unchecked. Okay, so we're getting close to the end here. I just want to talk about so for more information, if you want to get some of the reference material that I use to build this presentation, and there's also this awesome solution article. So if you log into my SolidWorks or your customer portal and go to knowledge base and search solid practices and that S076063, that it's a 10-page PDF that SolidWorks updates every 6 to 9 months or so. And it has very, very detailed specific settings and recommendations for working with large assemblies. So I know we're not talking about large assemblies here, but I know for those of you who you are always looking for better performance. Take a look at that one. That is a fantastic article to review. Also, we mentioned the SolidWorks RX benchmark. There's also some other tools in SolidWorks like this assembly visualization. and where you can analyze your assembly to look at how many actual graphical triangles, how long it took to open, and how long it took to rebuild certain components. So that way you can maybe take a look at, okay, my assembly is performing slowly. Is it just my assembly, or is it maybe a part file in my assembly that's causing that drag? Or maybe it's a set of files, and you can interrogate those further. So it's just informational, but awesome way to take a look at that. It's under your tools performance setting once you have an assembly open. There's also under that performance evaluation, another analysis tool. That same thing, if you open up SolidWorks and assembly, go to tools performance, it's listed there. This gives you a quick at a glance view of all performance for the file that you have open. So including triangles, how long it takes, if you have circular references, how many mates you have, and it makes some recommendations about, by the way, this is a pretty high amount of triangles. You may want to consider, reducing that somehow, like reducing your image quality or something like that. Very useful. We use that in tech support all the time when looking at, slow files. And then this is for parts. So parts do have their own assembly or own performance evaluation functionality. But again, we're not talking about mates and things like that, but we're looking at features usually with a specific part file. So this will give you a list of features in your part that then you can help that identify which feature might be causing the greatest delay when it comes to rebuild times. And maybe you look at reordering that, or maybe simplifying it and help improve those rebuild times. The other thing that I wanted to list here are just some of the websites that I use when I'm doing a lot of this research. So there's the Intel Workstation Configurator. Every machine you see listed on that site, I think, is on the hardware certification page for SolidWorks. They all have high-end Intel devices, high-end AMD or NVIDIA graphics cards. The hardware certification site, again, we talked about that. It's a great place to look at what SolidWorks has actually certified and what's gone through their lab and testing procedure. And then lastly, the benchmark site. So there's the SolidWorks benchmark, so you can compare your RX benchmark results against others in the community. And then the last one is a link to the latest Puget Systems benchmark for the Intel processors, but they're constantly adding new ones out there. They've got one on AMD out there now too. So take a look at their site. They've got some great stuff. So that about wraps it up. If you have any questions, here's our contact information. Again, thanks everyone. It's awesome to see the enthusiasm about performance. I know everyone loves seeing their SolidWorks perform better and better. This is a presentation that I like to do every year or so, and I try and update it with the latest technologies and latest chips that are coming out. So keep an eye on our site for when we post this one, for the next one we do. Again, if you're looking for hardware like components, Google 2021 Hawkridge Systems System Recommended Guide. We have that published right now, and we have specific GPUs, CPUs, and things like that listed. I do need to update it in a few months to make sure it's current, but yeah, it's pretty accurate still. Thanks everyone. Have a good day.